Okay, it is good to see you sort of here today and to talk a little bit more about Algebra 2. This is our last section in Chapter 2. Woohoo! Graphing inequalities. And after the last section, 2.6, 2.6 was heavy. So 2.7 is not as heavy. It's got some work in it. So I think you'll enjoy this section a little bit. So our assignment for this section is going to be pages 98 to 99, numbers 32 to 29 odd, and then these four problems, 33, 43. 33, 34, 42, 43. All right, so let's go ahead and take a look. Our only vocabulary word today is boundary. And what we're going to be dealing with in this section is we're going to be drawing graphs and doing some shading. And so when we draw graphs, we're going to be dealing with linear, I think primarily linear. I need to look over the examples again, but primarily linear inequalities. And we will be, like this line splits this coordinate plane into two very distinct boundaries. And so we might have one boundary that is below the line and another boundary that is above. And so we'll have boundaries that we are dealing with. So the answer might be this line included with all of this boundary, or we might have a boundary that's not solid. And so a non-solid boundary would be a dotted one. And so I know this sounds crazy right now, but it'll make sense in the example. It'll have a dotted line as the boundary. And we might say, oh, well, as the boundary marker, and then we only want this half of the plane. So the boundary is the line that we're drawing, and this is the half of the plane that we're going to shade. Sometimes we'll shade above, sometimes we'll shade below. So that's what a boundary is. A boundary is the line that we're going to draw in reference to the inequality. All right, so our first example is the dashed boundary. So right here, when you see this inequality, I want you to recognize that it looks a lot like a regular old-fashioned linear equation where we would, in standard form, where we'd have 2x plus 3y is equal to 6, right? But that's not exactly what we have. But we're going to use this as a guide. How would I handle this problem? What I would do is I would definitely, I think you probably would too, you would definitely take it and solve for y. In this case, we're going to solve for y in this inequality. So that means throwing the 2x over to the other side. So we get 3y is greater than negative 2x plus 6. And then I'm going to divide everything by 3. Okay? And so what I get is the boundary line is negative 2 over 3x plus 6 divided by 3 is 2. So I get the boundary line is y is equal to negative 2 over 3 x plus 2. Okay, so we're looking for all of the xy points that are going to satisfy this inequality. But first, let's look for the boundary line. So I solved for y within my inequality, and then created I'm going to call it a corresponding boundary line equation. So I'm going to graph this line, and I'll graph it by starting at the y-intercept, because it's in slope-intercept form, which is my favorite. I'm going to go up to the y-intercept, which is 2, and I'm going to use this slope to maneuver. So my slope is negative 2 over 3, so rise 2, go down 2, go to the right 3. 1, 2, 3, boom. Rise 2, go down 2, go to the right 3, 1, 2, 3. So now I've got this line, right? And I can draw the boundary line. But, trying to be slick here, but the problem is sometimes our boundary line isn't solid. That's if it's not included in the answer. And so in this case, it says y isn't equal to this part, like this is saying. It says y is greater than. So when we don't have the telltale extra line underneath our inequality sign or the equal to sign, we cannot have a solid line here. So this guy is actually going to be dotted. So now, you saw I started dotting it before because I anticipated the answer. Now we're going to go through and dot this. And let me use the white to go ahead and give it a dotted appearance. Okay? So now instead, our boundary line is going to be a dotted line to say, hey, we need to be careful of this mark. But all the answers that are going to satisfy this inequality will be found where y, now this is how I do it. There's a couple other different methods of doing it. Some teachers will tell you to pick a point in either one of these, on either side of these half planes, right? So you can pick a point like, say, 0, 0. And then you plug it in as an answer, 0 minus 2 over 3, 0 plus 2. And then you see if it's true. So is 0 greater than a positive 2? Since the answer is no, you know the answer to your questions isn't going to be in this side. Because 1 point failed in this half, then it must be the other side. So then some schools of thought will tell you to go ahead and shade on this side. And this is truly the correct answer, okay? So this is not how I'm going to tell you to do it, because I think that there's a simpler way, and we'll discuss it in just a second. But that's totally a way. So what we call the point that I chose 0, 0 because it was distinctly in a different zone or in a different half of the plane. It's called a test point. You plug the test point in. If the test point works, then that's the side you want. I generally don't do test points, though they're a totally good idea. What I do is I look at the problem and I say, hey, y is greater than. And I ask myself, if I'm talking about y, if I'm standing here and if I'm talking about y, I'm on the line, right? I know it's a dotted line because it didn't have that equal sign. But if I'm on the dotted line and I'm talking about y's being greater than, I'm talking about all the y's above this line. So that's how I do it instead of doing the test point. And sometimes students find it kind of confusing to do it this way. Other times they don't. It has never failed me in 40-something years of math. So you can go about it either way. So this is the answer or the graph of this inequality. Let's try another one. So sometimes we have a solid boundary, and let's see what this word problem is going to bring us. So a mail order company is hiring temporary employees to help in their packing and shipping departments during their peak season. So we're going to write an inequality to describe the number of employees that can be assigned to each department if the department has 20 temporary employees. Well, there's two departments we're talking about. We're talking about the packing department and the shipping department. And let P represent the number of people that's going to be sent to the packing department, and similarly let S refer to the number of people being sent to the shipping department. And so I know if I take these people and add them up, all the people to the packing department and all the people to the shipping department, if the company only has 20 temporary employees available, then that number has to be less than or equal to the 20, right? I can't have more than the 20, because if I only have 20 that are available, that's all I have, all right? And so now we've got to graph P and S. And so when we do this, we're going to graph the relationship on an XY axis, all right? And so similarly, let's call it a PS axis. So let the packing department be down here and let the shipping people be up here. And notice I don't have like the negative parts because I can't really talk about negative people, right? So what I'm going to do is I'm going to solve as I usually would. So I'm going to solve for S because S is in my Y place. So S is subtract P from both sides, right? S is going to be less than or equal to, this equal to tells me it's a solid line, people. S is less than or equal to negative P plus 20. And so I can make my axes, let's see, I can label my axes. I can count by, I don't know, I can count by fives, 5, 10, 15, 20, 25, 30. So let this be 30. And I'm going to do the same thing here. 5, 10, 15, 20, 25, and 30. And so now, let me put the P out here and the S up here. Okay, good. So now that I have that, I'm going to just graph this line, right? And so to graph it, my y-intercept is at 20, or my s-intercept is at 20. So 5, 10, 15, 20. And my slope is negative 1, right? That's the coefficient of P. So it means for every time I go down 1, I got to go over 1, down 1, over 1, down 1, over 1. So what it really means is if I go down 5, remember this space is 5, I've got to go over 5. Down 5 over 5. Down 5 over 5. And that will be a 1-to-1 relationship, and that gives me back over here at 20. And this is going to be a solid line. Let me change my color just for fanciness. This is going to be a solid line from here to here. And then I know that the S value is less than or equal to. So that tells me that I'm shading below. Where is S less than? Down. So I would shade below this line. And since we're only dealing with the positive region, I'm stuck in this little triangle here. So I don't shade all the way over here. So what does this mean? This really means, and this should be kind of sensible, I can have 20 people working in the packaging and 0 people, because that's this point is 20, and 0 people working in shipping, right? I can have 0 people working in packaging and 20 people working in shipping. That's just what these values mean. Over here, this point here is like 5, 5. I could have, with this number, with this restriction of 20 temporary employees, I could put 5 people in packaging and 5 people in shipping. In fact, any of these dots here are going to represent possibilities, possible solutions to our situation. So that's why this graph works, and it shows the solutions that work in this inequality. Can the company assign 8 employees to package and 10 employees to shipping? Well, let's think. 8 would be, this is 5, this is 10, 8 is around here, and 10 is up here, and that point falls within our boundary. So since this point is 8 to 10, packaging, shipping, we know that that is a possibility. And basically, once it stays under 20, we see that it works. Make sense? I hope it's not too bad. All right, the last thing we have to do, I think this is our last example, so this is a shorter lesson than usual. Our last thing we have to do is we're going to graph an absolute value inequality. So again, we are thinking about the related equation, f of x is equal to the absolute value of x plus 1. Notice that this is not, the equal to isn't there, so this tells me I'm going to have a dotted boundary. But this boundary is going to be different because this boundary is going to be a v, an absolute value equation, which you're probably tired of from the last example, from the last section rather, pardon me. So a couple ways of doing this. After doing so many absolute values, I'm sure you're tired of them, but one surefire way is just to go ahead and plug in some values and do it -3, -2, -1, 0, 1, 2, and 3. Plug them up in here and I get 4, 3, put -1 in there, I get 2, 0, I get 1, 1, I get 2. I see the bend here, right? 2, I get 3, and 3, I get 4. Plug these bad boys into right onto my graph, pardon me. I get -3 goes to 4, -2 goes to 3, -1 goes to 2, 0 goes to 1, 2 goes to, 1 goes to 2, 2 goes to 3. I see my beautiful bend. I see what's happening, right? As we said, this is not part of the solution here. This is a boundary for the solution. So f of x equaling to absolute value of x plus 1 is not a part of the solution because f of x must be less than x plus 1. So since it's not a part of it, I've got to dot this thing out. So it's going to be a dotted line. That's important because it's not equal to. And then since it's less than, again, I could do the point test, choose a point here, plug it in, see if it works. But I've been doing this for years. F of x is less than, since f of x or y being less than is below, I'm going to shade everything below. And that's where I'm going to go. And then so everything underneath this graph is a part of the solution set. And you can take a test point and check it out. In this situation, we see that 0, 0 is a part of our solution set. Does 0, 0 work? Simply put a 0 here and a 0 here. Well, and we're dealing with the inequality here. So if I put a 0 here, is 0 less than 0 plus 1? Yeah, it is. 0 is less than 1, so I know that I got the correct section. All right, so short lesson, not a whole lot of examples, so please make sure you're mindful as you look at it and make sure you get down these problems and let's talk about it. This section is, as with the last section, is going to be kind of graph heavy, so make sure you have enough graph paper and you're trying to be as neat as possible so we can really check your answers together the next time I see you. Take good care and I'll talk to you soon. Bye-bye.